Welcome back for another deep dive from Peaceful Rooster Experience. Today, we're going to be tackling something that's absolutely crucial in our data-driven world,
Yeah,
streaming data pipelines.
absolutely.
You might not be a data scientist,
Right.
but trust me, this stuff is everywhere behind the scenes.
Yeah.
Think of it like this.
Okay.
You know how a highway constantly has cars zooming by?
Mm-hmm.
That's kind of what streaming data is like.
Yeah.
A nonstop flow of information.
Mm-hmm.
And we're going to figure out how to make sense of it all using some fascinating notes we have from a book chapter all about stream processing platforms.
What's really cool about this continuous flow is how it allows for real-time insights.
Right.
You know, it's not just about storing the data, it's about analyzing it on the fly to make decisions as things happen.
Right. It's like the difference between reading a history book and watching a live news broadcast.
Yeah.
We're not just looking back, we're understanding the present as it unfolds.
Exactly.
But before we can even start building these pipelines, our notes stress the importance of something that might not sound very glamorous.
Okay.
Data preparation.
It's a bit like building a house, you know?
Okay.
You wouldn't just start throwing up walls without a solid foundation, would you?
Right.
Data preparation is all about getting that foundation right.
So walk me through it. What are the steps involved in creating this data foundation?
Well, the first step is data cleansing.
Okay.
Imagine a giant spreadsheet with customer data, but it's full of typos.
Oh.
Missing zip codes and addresses formatted in a million different ways. Data cleansing is like taking a deep breath
Okay.
and meticulously cleaning up that mess.
It sounds a bit tedious, but I can see how crucial it is. Garbage in, garbage out, as they say.
Exactly. And it's not just about fixing errors. It's also about standardizing formats so that everything is consistent
Yeah.
and can be easily processed.
Okay.
You might even need to fill in some gaps using external sources. Think of it as turning a chaotic data jungle into a well-organized library where everything is easy to find.
I like that analogy.
Yeah.
Okay, so I've got a clean and organized data set. What's next?
Then comes data transformation,
Okay.
where we tailor the data to fit our specific needs.
Mm-hmm.
Our notes compare it to tailoring a piece of clothing. You know, you might need to take in the seams
Yeah.
or adjust the length to get the perfect fit.
Okay.
For example, you might have dates in your data set stored as text, like
Okay.
January 1st, 2024.
Uh-huh.
To analyze that data effectively, you'd want to transform that into a standard date format.
Right.
Like a 2024 0101.
Makes sense. It's all about making the data work for us, not the other way around.
Absolutely. And finally, we have data enrichment,
Okay.
which is like adding those little details that make something truly special.
Ooh.
Imagine a data set of customer purchases.
Yeah.
By enriching it with demographic data like age or location,
Uh-huh.
or even behavioral data like browsing history, we suddenly have a much richer understanding of our customers.
Wow.
It's like taking a black and white photo and adding color to it.
So we've cleaned, transformed, and enriched our data. It sounds like it's finally ready for the highway,
Yes.
the streaming data pipeline.
Exactly. Remember that highway analogy we talked about earlier?
Yes.
That's the perfect way to visualize how data flows continuously in a streaming pipeline.
okay.
And it's this continuous flow that allows us to do some pretty amazing things in real time.
Okay, give me some examples.
Yeah.
What kind of real-world magic can we achieve with these pipelines?
Think about fraud detection.
Okay.
As transactions happen, streaming pipelines can analyze them on the fly, looking for suspicious patterns,
Right.
and flagging potentially fraudulent activity before it even impacts the customer.
That's incredible.
Or imagine personalized recommendations on your favorite shopping website.
Ooh, like that.
As you browse, streaming pipelines can analyze your behavior and suggest products you might be interested in, making the whole shopping experience more relevant and engaging.
It's like having a personal shopper who knows exactly what you want before you even realize it yourself.
Exactly. And then there's network monitoring.
Okay.
Streaming pipelines can keep a constant eye on network traffic, looking for anomalies that might indicate an outage or security breach.
Oh, right.
This allows for proactive intervention, preventing problems before they even occur.
Wow, it sounds like streaming data pipelines are the unsung heroes of the digital world, quietly working behind the scenes to make everything run smoothly and securely.
They really are.
But how do we actually build these pipelines?
Yeah.
Our notes mention two main patterns,
Okay.
ETL and ELT.
Right.
What's the difference?
They both involve extracting, transforming, and loading data,
Okay.
but the order is key.
Okay.
ETL, which stands for extract, transform, load,
Okay.
is the traditional approach. It's like carefully sorting and organizing all your belongings before moving into a new house.
Oh.
You clean and transform the data before loading it into its final destination, typically a data warehouse.
So it's all about getting everything perfect before you move it in. What about ELT?
ELT, or extract, load, transform, is more like moving everything into your new house first and then organizing it once it's there.
Okay.
You load the raw data directly into a system like a data lake,
Right.
and then perform the transformations within that system.
It seems like ELT would be a lot faster, especially if you're dealing with a lot of data. But does it work for real-time streaming?
That's the beauty of it. ELT can be adapted for real-time streaming.
Oh, wow.
Think of it like unpacking boxes as they arrive,
Yeah.
instead of waiting for the entire moving truck to be unloaded.
Okay.
Our notes give an example of a retail company loading raw sales data into a data lake. Then a stream processing engine analyzes it in real time, enriches it with product information, and calculates those crucial sales metrics on the fly.
Wow. It's all happening live. That's incredible.
Yeah.
So we've got our data prepared. We've chosen our pipeline pattern.
Yes.
And we're ready to start processing those real-time streams. But what happens next? How do we actually make sense of this continuous flow of information?
That's where stateful transformations come in.
Okay.
Imagine a chef who remembers the ingredients and steps of a recipe while cooking.
Good.
Stateful transformations are similar. They remember past data to perform more complex calculations.
It's like having a memory for your data stream, right?
Exactly. This allows for things like calculating rolling averages, identifying user sessions, and removing duplicate records.
Yeah.
All of which require remembering past data points.
So it's not just about looking at each data point in isolation. It's about understanding its context within the larger stream. That's where things get really interesting.
Absolutely. Think about how streaming services recommend what you should watch next.
Oh, yeah.
They're analyzing your viewing history,
Right.
remembering what you've liked and disliked, and using that information to suggest new content.
It's like having a friend who knows your taste in movies so well that they can always recommend something you'll love.
Exactly. That's the power of stateful transformations in action.
But all of this magic requires some pretty sophisticated technology, right?
Okay.
What are these stream processing platforms that make it all happen?
They're like the control centers for managing these real-time data streams.
Yeah.
They provide all the essential capabilities to make the magic happen, from handling the continuous flow of data to performing complex calculations and managing state.
So what are some of these key capabilities that we should know about?
One of the most important is event time processing.
Okay.
Our notes use a great analogy to explain this.
Okay.
Imagine a package delivery service that timestamps packages when they're picked up,
Okay.
not when they arrive at the sorting facility.
That makes sense.
Yeah.
You want to know when something actually happened, not just when you received the information about it.
Exactly. Event time processing ensures that data is processed based on when the event actually occurred, not when it was received.
Right.
This is crucial for maintaining data accuracy, especially when data might arrive out of order due to network delays or other factors.
It's like reconstructing a timeline of events based on when they actually happened, regardless of when the information reached us.
Another key capability is windowing, which is like dividing a continuous stream into smaller, more manageable chunks for analysis.
Okay.
It's like analyzing website traffic hour by hour instead of trying to make sense of the entire day's data at once.
So instead of looking at the entire fire hose of data, we're breaking it down into smaller, more digestible sips.
Exactly. Windowing allows us to apply calculations and transformations over specific time intervals,
Right.
making it easier to identify patterns and trends within the data stream.
And of course, we need a way to store and manage the state that we talked about earlier.
Right. State management is essential for enabling complex computations.
Yeah.
And maintaining context across the stream, it allows us to perform operations that acquire knowledge of past events and their impact on the current state.
It's like having a memory for the data stream, remembering what's happened before so we can understand what's happening now.
And we can't forget about fault tolerance.
Right.
What happens if a system crashes?
Oh.
We need to make sure that no data is lost and that processing can resume smoothly.
It's like having a backup generator for your data stream in case of a power outage. The backup kicks in and keeps everything running.
Exactly. Fault tolerance is critical for ensuring data reliability and preventing disruptions.
Okay.
And finally, we need our platforms to be scalable.
Okay.
As the volume of data grows, our systems need to be able to handle it without slowing down.
Right. It's like having a highway that can expand to accommodate more traffic without causing gridlock.
Exactly.
So we've covered a lot of ground here.
Yeah.
We've talked about the importance of data preparation, the different patterns for building streaming pipelines,
Yes.
the power of stateful transformations, and the key capabilities of stream processing platforms. Where do we go from here? What are some specific examples of these platforms that are out there in the wild?
Well, there's a whole ecosystem of stream processors, each with its own strengths and weaknesses. One example is Kafka Streams, a JVM-based library that's part of the Apache Kafka project.
Kafka Stream's interesting. What's special about it?
It allows developers to build real-time applications that can directly consume, process, and produce streams of data from Kafka, making it a popular choice for organizations already using Kafka for their messaging needs.
So it's all about that tight integration with Kafka. What other options are out there?
Another popular choice is Apache Flink,
Okay.
which supports both batch and stream processing. What's interesting about Flink is that it views batch processing as a special case of streaming.
Oh,
Kind of like saying that a still photograph is just a very short video.
that's a really interesting way to think about it. So Flink sees everything as a stream, whether it's a continuous flow of data or a single batch of information.
Exactly. This unified approach makes Flink very versatile and well-suited for a wide range of data processing tasks.
Okay.
And Flink is also cluster-based,
Okay.
meaning it can be distributed across multiple machines for increased performance and scalability.
That makes sense. If you're dealing with massive amounts of data, you need a system that can handle the load.
Right. And then there's Spark Structured Streaming,
Right.
which is part of the Apache Spark ecosystem. It uses mini batching,
Okay.
which means it processes data in small batches rather than continuously.
So it's like finding a balance between the real-time capabilities of streaming and the efficiency of batch processing.
Exactly. This approach provides a good compromise for applications that need near real-time insights, but don't necessarily need millisecond-level latency.
Makes sense. What other options are out there?
We also have Apache Samza,
Okay.
which was initially developed by LinkedIn.
Okay.
It supports a variety of data sources and is also cluster-based like Flink.
Samza from LinkedIn. What are its strengths?
It's known for its fault tolerance and scalability, making it suitable for mission-critical applications where data reliability is paramount.
So it's the workhorse of the stream processing world.
You could say that. And then there's Apache Beam,
Okay.
which is a bit different from the others.
Okay.
It's not a stream processor itself,
Okay.
but a unified model for writing data processing jobs that can be executed on various engines like Flink, Spark, Samza,
Uh-huh.
and even Google Cloud Dataflow.
So it's like a universal language for stream processing.
Exactly. Beam provides a level of abstraction that allows developers to write portable data processing pipelines that can run on different platforms.
Wow.
This makes it easier to migrate workloads or choose the best engine for a specific task.
That's pretty powerful. So we've got Kafka Streams, Flink Spark Structured Streaming, Samza, and Beam. A whole arsenal of tools for tackling the challenges of stream processing. It's like having a toolbox full of specialized wrenches,
Yeah.
each designed for a specific type of bolt.
The key is choosing the right tool for the job, understanding the strengths and weaknesses of each option, and selecting the one that best fits the specific needs of your application.
And speaking of tools, our notes also mention something called materialized views. What are those?
Materialized views are like pre-calculated reports already stored and updated,
Okay.
so you don't have to run complex queries every time you need the information.
Got it.
They can significantly speed up data access and reduce the load on your system.
It's like having the answers ready before you even ask the question.
Exactly. Our notes give a great example.
Okay.
In a stock trading application, a materialized view could store the current price of each stock.
Okay.
Updated in real time, this would make it much faster to display the prices to users.
It's like having a live ticker tape that automatically updates itself
Right?
without you having to constantly refresh the data. That's pretty cool. So we've covered a lot of ground here. We've explored the different ways to prepare data, the patterns for building streaming pipelines, the power of stateful transformations, and the key capabilities of stream processing platforms.
Mm-hmm.
We've even looked at some specific examples of these platforms and learned about materialized views. But our journey isn't over yet. What else is there to discover in the world of streaming data?
Well, there's still much to explore. We haven't even touched on the different types of streams you might encounter, each with its own unique characteristics and considerations.
Different types of streams? Tell me more. What can we expect to see in the next part of our deep dive?
We'll delve into the world of change streams, which are like logbooks of changes,
Okay.
and append-only streams, which are like security camera recordings capturing events as they happen.
Oh, that sounds interesting.
We'll also explore the challenges and considerations of building and managing these streaming pipelines in real-world scenarios.
Sounds fascinating. I can't wait to learn more about these different types of streams and the challenges that come with managing them. So stay tuned for the next part of our deep dive, where we'll continue our exploration of the fascinating world of streaming data pipelines.
Welcome back to our deep dive into streaming data pipelines. Last time we left off with a tantalizing glimpse into the world of stream processors.
Right, those engines that power real-time data analysis.
Exactly. We've already touched on some heavy hitters like Kafka Streams and Flink, but there's a whole ecosystem of tools out there, each with its own unique approach.
It's like we've stepped into a bustling marketplace of streaming processing solutions. What other interesting options are out there?
Well, for starters, we have Quick Streams, unlike Kafka Streams, which is JVM-based.
Right.
Quick Streams is a library built for C# and Python developers.
So if you're not fluent in Java, there are still powerful tools available. It's like choosing your preferred language for speaking with a data stream.
Exactly. And speaking of languages, we also have Bytewax,
Okay.
another Python-based library. But what's fascinating about Bytewax is that it leverages something called timely data flow for processing.
Timely data flow. That sounds intriguing. What's the advantage of that approach?
Timely data flow is all about ensuring that computations are completed in a timely and consistent manner, even when dealing with out-of-order or late-arriving data.
Oh, that's handy.
It's like having a conductor who keeps the entire orchestra synchronized, even if some musicians are slightly offbeat.
So it helps us maintain order and accuracy in the midst of a chaotic data stream.
I like it. What other tools are out there that use interesting approaches?
There's Pathway, another Python-based library, but it uses differential data flow.
Okay.
DD, as its engine, DD focuses on incremental computation,
Okay.
which means it only recomputes the parts of a calculation affected by changes in the data.
So instead of recalculating everything from scratch every time, it just updates the parts that need updating? That sounds incredibly efficient.
It is, especially when dealing with complex computations involving large data sets. It's like updating a spreadsheet,
Yeah.
where only the cells affected by a change are recalculated rather than redoing the entire sheet. That's a great analogy. It makes the concept of incremental computation much easier to grasp. Are there any other tools you want to highlight before we move on?
One more that's worth mentioning is Estuary Flow.
Okay.
It's a cluster-based processor that supports a wide range of connectors, making it incredibly versatile.
So it's like a universal adapter for streaming data.
Exactly. And it's designed to be highly scalable and fault-tolerant, making it suitable for handling massive data streams in demanding environments. It's like having a data pipeline that can withstand anything you throw at it.
Okay, so we've explored a wide range of stream processors, each with its own unique strengths and approaches. It's clear that there's no one-size-fits-all solution, but rather a rich tapestry of options to choose from. But let's shift gears for a moment and revisit a topic we touched on earlier, materialized views.
Ah, yes. Materialized views, those pre-calculated reports that can significantly speed up data access and reduce the load on your underlying data sources.
Right, instead of querying the raw data every time we need information.
Yeah.
We can simply access the pre-computed results in the materialized view. It's like having a shortcut to the information we need without having to go through the entire calculation process each time.
Exactly. And this can be a real lifesaver in scenarios where you have high query volumes or strict latency requirements. Imagine you're running a stock trading application.
Okay.
And you need to display real-time stock prices to your users.
Yeah.
Instead of querying the data stream every time a user requests a price, you can create a materialized view that stores the latest prices updated continuously.
So when a user wants to know the price of a particular stock, the information is already there, ready to be displayed instantly. It's like having a magic mirror that shows you the information you need without any delay.
Exactly. Materialized views can be incredibly powerful tools for making your streaming pipelines more efficient and responsive. And they're not just limited to storing raw data.
Right.
They can also be used to perform aggregations and other computations,
Yeah.
making it easier to derive insights from your data stream.
So it's not just about speeding up access to raw data. It's about pre-computing the answers to common questions so that we can get insights faster. That makes a lot of sense. Okay, so we've revisited materialized views. What other topics do we need to cover in this part of our deep dive?
Well, we can't forget about the different types of streams that exist out there.
Right.
Remember, we have change streams, which are like logbooks of changes.
Yes.
and append-only streams, which are like security camera recordings capturing events as they happen.
Right. We briefly touched on those in the previous part. Can you elaborate on those a bit more? What makes each type of stream unique?
Change streams are particularly useful for tracking the evolution of data over time.
Oh?
They allow you to see how data has been modified,
Hmm.
who made the changes, and when they occurred.
It's like having a detailed audit trail for your data.
Right.
This can be invaluable for debugging, auditing, and understanding the history of your data.
Exactly. You can see how a customer's profile has evolved over time, track the changes made to an order, or even monitor the edits made to a document.
It's like having a time machine for your data, allowing you to rewind and see how things have changed. That's incredibly powerful. What about append-only streams? How are those different?
Append-only streams are ideal for capturing a continuous feed of events. They provide a chronological record of everything that has happened, making it easier to reconstruct timelines and analyze patterns over time.
So instead of tracking changes to existing data, we're simply adding new events to the stream as they occur. It's like writing a never-ending story with each new event adding another chapter to the narrative.
Exactly. Think about monitoring website traffic.
Okay.
An append-only stream would capture each click, page view, and interaction, allowing you to see the user journey unfold in real time, or imagine monitoring sensor data from a fleet of vehicles.
Okay.
Each new data point from each sensor would be appended to the stream, providing a continuous record of the vehicle's locations, speeds, and other metrics.
It's like having a live feed from each vehicle, allowing us to track their every move. That's pretty cool. But with all this real-time data flowing in, there must be some challenges in managing these streaming pipelines.
Yeah.
What are some of the key considerations we need to keep in mind?
One of the biggest challenges is ensuring data quality. When you're dealing with a continuous stream of data, it can be difficult to catch errors and inconsistencies in real time.
Right.
Data can arrive out of order, be duplicated, or contain inaccuracies. It's like trying to drink from a fire hose. You're getting a lot of water, but it's hard to make sure it's all clean and drinkable.
So what can we do to ensure data quality in a streaming environment?
Robust data validation and cleansing techniques are crucial.
Okay.
We need to establish mechanisms to identify and handle data quality issues before they propagate through the pipeline. It's like having quality control checkpoints throughout a manufacturing process,
Yeah.
catching defects before they reach the final product.
That makes sense. We need to make sure that the data flowing through our pipelines is reliable and trustworthy. What other challenges do we need to be aware of?
Managing the complexity of these pipelines can be a real headache.
Okay.
As they grow in size and scope, it can become difficult to monitor, debug, and maintain them. It's like trying to untangle a giant knot of wires. It can quickly become overwhelming.
So how do we keep these pipelines from becoming a tangled mess?
This is where concepts like lineage tracking and data observability come into play.
Okay.
We need to be able to trace the origin of data, understand its transformations, and monitor its quality throughout its journey through the pipeline.
It's like having a map of the data pipeline showing us where the data comes from, where it goes, and what happens to it along the way.
Exactly. This visibility allows us to identify and address issues quickly and effectively, and then there's the challenge of choosing the right infrastructure.
Right.
Streaming pipelines can be deployed on premises in the cloud or in hybrid environments.
So we have options in terms of where we run these pipelines.
Yes, each deployment model has its own trade-offs in terms of cost, scalability, and security. We need to carefully evaluate our requirements and choose the infrastructure that best meets our needs.
It's like choosing the right vehicle for a journey. A compact car might be fine for a short trip around town, but for a cross-country road trip, you'll need something more robust and spacious.
Exactly. And of course, we can't forget about security. Streaming pipelines often handle sensitive data,
Right.
making security a top priority.
That's right. We need to make sure that the data flowing through our pipelines is protected from unauthorized access and tampering.
Absolutely. We need to implement appropriate measures to protect data at rest and in transit, and to control access to our systems.
So it's not just about building these pipelines. It's about building them securely and responsibly.
Exactly. Security should be baked into the design from the very beginning. It's not something you can just tack on as an afterthought.
So we've explored the challenges of ensuring data quality, managing complexity, choosing the right infrastructure, and maintaining security. It seems like building and managing these streaming pipelines is no easy feat.
It's definitely not for the faint of heart, but the rewards can be significant.
Yeah.
Streaming pipelines enable us to harness the power of real-time data, gain valuable insights, and make data-driven decisions that can have a real impact on our businesses and our lives.
It's like having a crystal ball that shows us what's happening right now, allowing us to make better decisions in the present and shape the future. But there's still more to explore what other insights await us in the final part of our deep dive.
Welcome back to our deep dive. It feels like we've been wading through a river of data.
We have. It's been quite a journey through this fascinating world of streaming data pipelines, hasn't it?
Yeah, from that meticulous process of data preparation
Right.
to the intricate dance of stateful transformations, we've explored how these pipelines empower us to harness the incredible potential of real-time data.
It's been like assembling a complex puzzle, piecing together the different components and understanding how they all work together to create this powerful engine for insights. But before we conclude our deep dive, I think it would be helpful to step back and reflect on some of the key takeaways.
Yeah.
What are some of the most important lessons we've learned along the way?
I think one of the most fundamental takeaways is the transformative power of streaming data itself.
Right.
It's not just about storing the data, it's about analyzing it as it's generated, allowing us to respond to events and opportunities in real time.
It's like the difference between reading a history book and watching a live news broadcast. We're not just looking back, we're understanding the present as it unfolds.
Right, and we've seen how this real-time capability is being used in a wide range of applications.
Yeah, absolutely.
From fraud detection and personalized recommendations to network monitoring and predictive maintenance. It's truly revolutionizing the way businesses operate and how we interact with the world around us.
And we've also learned that building these streaming pipelines is no trivial task. It requires careful planning, a deep understanding of the underlying technologies, and a keen eye for detail.
Oh, absolutely. We've explored the critical importance of data preparation, ensuring that the data flowing through our pipelines is clean, consistent, and reliable. We've delved into the different patterns for building these pipelines, from the traditional ETL approach to the more modern ELT paradigm, understanding the trade-offs and considerations for each. And we've even journeyed into the world of stream processors, examining the diverse approaches they take to handling real-time data,
Right.
from mini-batching to incremental computation.
It's been quite a whirlwind tour of the streaming data landscape.
It has.
And let's not forget about those materialized views, those pre-calculated reports that can significantly speed up data access and simplify our queries.
Right.
They're like having a cheat sheet for our data, giving us instant answers to common questions.
Yeah, they're a great example of how we can optimize our pipelines for efficiency and performance, ensuring that we can derive insights from our data as quickly as possible. And we can't overlook the importance of understanding the different types of streams we might encounter, change streams,
Yes.
which track the evolution of data over time, and append-only streams, which capture a continuous feed of events.
Right.
Knowing the characteristics of each type of stream is crucial for choosing the right processing techniques and designing our pipelines effectively.
It's like choosing the right tool for the job.
Yeah.
You wouldn't use a hammer to screw in a light bulb, would you?
You would not.
Similarly, you need to select the right processing approach based on the type of stream you're dealing with.
Exactly. And we've also explored the challenges that come with building and managing these streaming pipelines in the real world.
Right.
From ensuring data quality and managing complexity to choosing the right infrastructure and maintaining security.
It's not always easy, but the rewards can be significant.
The rewards are huge.
It's like navigating a complex maze, but the treasure at the end is worth the effort. But as we conclude our deep dives, I think it's important to remember that this is just the beginning. The world of streaming data is constantly evolving, with new technologies and techniques emerging all the time.
Absolutely. And as the volume and velocity of data continue to grow, the importance of streaming data pipelines will only increase during PM. They'll become even more essential for businesses to stay competitive, make informed decisions, and deliver innovative products and services.
So what does this all mean for our listeners? What should they take away from this deep dive into the world of streaming data pipelines?
I think the most important takeaway is that streaming data is no longer a niche technology.
Right.
It's becoming the backbone of modern data-driven applications and systems, whether you're a data scientist, a software engineer, or simply someone interested in the power of data.
Right.
Understanding the fundamentals of streaming data pipelines is becoming increasingly important.
It's no longer a question of if, but when you'll encounter streaming data in your work or your life. And this deep dive is hopefully giving you a solid foundation to understand how these pipelines work,
Yes.
the challenges they address, and the incredible opportunities they unlock.
It's been an exciting journey, and I encourage everyone to continue exploring this fascinating world of real-time data. There's always something new to learn, and the possibilities are truly endless.
Well said. Thank you for joining us on this deep dive into the world of streaming data pipelines. Until next time, may your data streams flow smoothly and your insights be insightful.